Class 12, Subject Physics, Exam Pattern. First we know the exam pattern. There are 33 questions are asked. All questions are compulsory. Section A consists of 16 questions of 1 mark each. Section B 5 questions, each carry 2 marks. Section C 7 questions, 3 marks each. Section D 2 case studies, 4 marks each. Section E 3 long answers of 5 marks each. Totally 33 questions, total marks 70. In this video, we will see the solutions for Section B. Section A, refer previous video. Sample paper 20, 23, 24. Questions. Question number 17. A. Name the device which utilizes unilateral action of a PN diode to convert AC into DC. Second question. Draw the circuit diagram of full wave rectifier. Answer. A. The device which utilizes unilateral action of a PN diode to convert AC into DC is rectifier. First we know what is a rectifier. Rectifier diode is a two-lead semiconductor that allows current to pass in only one direction. The process of conversion of AC voltage into DC voltage is called rectification, and the circuit used for rectification is rectifier. Second B. Diagram full wave rectifier. A PN diode is a type of semiconductor diode based upon the PN junction. The diode conducts current in only one direction, and it is made by joining P-type semiconducting layer to an N-type semiconducting layer. What is a full wave rectifier? A full wave rectifier is a rectifier which is used for converting both the half cycles of AC input into DC output. So, see the diagram. Here diode 1 and B is diode 2. Center tap transmission. Here center tap. X RL output. Question number 18. The wavelength of a photon and the de Broglie wavelength of mass m have the same value. Show that the energy of photon is 2 lambda mc by h times the kinetic energy of the electron, where c and h have their usual meanings. First read the question carefully. Wavelength of a photon. We know wavelength of a photon is lambda, and the de Broglie wavelength of mass m have the same value. Therefore, de Broglie wavelength for matter waves is equal to lambda is equal to h by mv. And then show that energy of photon. First we know energy of photon E is equal to hc by lambda. We have to prove that kinetic energy of the electrons is equal to 2 into lambda mc by h times. Therefore, kinetic energy of the electron. Kinetic energy we already know that Ke is equal to arm mv square. Using 1 and 2, we get the value of V is equal to h by lambda m. Using this value in kinetic energy of mv square, where V is equal to h by lambda square, on solving we get Ke is equal to of h square by lambda square by m. Then E by Ke. E, energy of photon. Hc by lambda. Kinetic energy, we have already find out, of Hc square by lambda square. On solving, we get E is equal to 2 lambda mc by h into k times. Hence proved. 19. A ray of monochromatic light passes through an equilateral prism in such a way that the angle of incidence is equal to the angle of emergence, and each of these angles 3 by 4 times the angle of the prism. Determine the angle of deviation and the refractive index of the glass prism. Given a monochromatic light passes through an equilateral glass prism. Given the prism is equilateral, therefore we know that all angles are 60 degree. Therefore, the angle of the prism, angle A, is equal to 60 degree. Then minimum deviation D is equal to capital D. I, angle of incidence, is equal to angle of emergence. We know that angle R1 plus angle R2 is equal to angle A by see here. Here angle A M in the quadrilateral, angle A plus angle O is equal to 180 degree. Therefore, angle A is equal to 180 minus angle O. Angle O is equal to, in this triangle, angle R1 plus angle R2 plus angle O is equal to 180 degree. Therefore, angle R1 plus R2 is equal to 180 minus angle. Comparing these two, we get angle R1 plus R2 is equal to angle A. Then angle D, deviation, is equal to angle I plus angle E minus angle A. Therefore, angle D plus angle A is equal to I plus E. But given angle I is equal to 3 by 4 times of angle A. So, angle A is equal to 60 degree. Therefore, we get angle I is equal to 45 degree, as well as angle E is also 45 degree. Therefore, angle D is equal to 30 degree. We get angle of deviation D is equal to 30 degree. According to Slent's law, refractive index n is equal to sin I by sin r. That is sin angle A plus D by 2 by sin of angle A by 2. Using this formula and given the values, we get refractive index angle n is equal to root 2. Question number. A heating element using nichrome connected to a 230 volt supply draws an initial current of 3.2 ampere, which settles after a few seconds to a steady value of 2.8 ampere. What is the steady temperature of the heating element? If the room temperature is 27 degree Celsius and the temperature coefficient of resistance of nichrome is 1.70 into 10 power minus 4. Solution given. B, 230 volt. Initial current I0 is given 3.2 ampere. After a few seconds, steady value of the current I1 is equal to 2.88. Room temperature T0 is given 27 degree Celsius. Coefficient of resistance also given, and alpha is equal to 1.10 power minus 4. We have to find steady temperature, that is T. We know the formula. R is equal to R0 into 1 plus alpha into changing in temperature. R is equal to V by I. that is V by I naught into 1 plus alpha into changing in temperature. If we replace the values, given values, we get 1 by 7 is equal to 1.70 into 10 power minus 4 changing in temperature. Therefore, changing in temperature is equal to, on solving we get 840 degrees Celsius. Then, changing in temperature is equal to steady temperature minus initial temperature. Therefore, steady temperature is equal to 867 degrees Celsius. Therefore, the steady temperature of the heating element of nichrome is 867 degrees Celsius. Question number 22. Show that the least possible distance between an object and its real image in a convex lens is 4f, where f is the focal length of the lens. So, first read the question fully. Given focal length is equal to f, we have to find the distance between an object and its real image in a convex lens is 4f. See here in the diagram, OA is the object, CB is the image. We have to find distance between O to C. O to C. Let it be, we will take that distance between OC is equal to D. Then, object distance U is equal to OT and X. Therefore, image distance is equal to NC is equal to D minus X. Using this, in lens formula, we get 1 by V minus 1 by U is equal to 1 by F. 1 by D minus X plus of 1 plus X is equal to 1 by F. On solving, we get x square minus xt plus fd is equal to 0. This is in the form of quadratic equation. Here a is equal to 1, b is equal to minus d, c is equal to fd. If x is real, we know that determinant is greater than 0. Determinant means b square minus 4a is greater than 0. Using substituting the real values, we get d is greater than or equal to 4f. Hence, the least possible distance between object and real image is 4f, hence proved. 21 or question. In an astronomical telescope, in normal adjustment, a straight black line of length L is drawn on the objective lens. The eyepiece forms a real image of this line whose length is 1. What is angular magnification of the telescopes? Solution. Angular magnification of the telescope M is equal to F0 by Fe. Here, ME magnification of the eyepiece lens is given Fe by Fu plus U. See the diagram. Fe is L1, Fe plus U is equal to L0. L1 is object eyepiece height, L0 is image height. ME is equal to Fe by Fe plus U is equal to L1 by L0. So, U is equal to, we know that, minus F0 plus Fe. Using this value, we get F0 by Fe is equal to L by 1 is equal to magnification M is equal to L.